Hello, my name is Michael Richardson. I'm going to be giving a deep dive into Build 3 of the IoT Open House. This is for BRSKI. You can find my slides with the QR code or the URL below. And we'll take some questions at the end. So what is BRSKI? It stands for Bootstrapping Remote Secure Key Infrastructure. Like all acronyms, we try hard to make sure interesting and useful, and you may be interested to know that BRSKI is a term that Canadians use to talk about beer, but also it turns out it's a Midwest thing for beer, and we worked pretty hard to make that all work out that way. But it stands for Bootstrapping Remote, meaning it's not a local thing, Secure Key Infrastructure. And so that's about bringing up a certificate on a device which has no interface. So what does it do? This is our agenda. We're going to talk about what is BRSKI, what does Build 3 do, and then finally we'll talk a little bit about how it's going to be changing in the future as things go forward. So what is the goal of BRSKI? It's to allow the network or operator to learn the identity of a new device. This is essentially comes from the IDEV ID, and a great deal of EST or RFC 7030 already did this a little bit, but is a little more nuanced. It's also allow the new device to learn the identity of the network operator, and this part is new and particularly important for IoT devices. And it allows the network to provide an LDEV ID to the new device, allowing it to authenticate to other devices that might also be on the network. And that's really the ultimate goal, is to secure everything through common connection to a trust anchor. And finally, interesting to know, BRSKI is at this point is an extension of EST, which is Enrollment Over Secure Transport, which is RFC 7030, which has been around for quite a number of years. So why did this happen and who did it? So about 10 years ago, there was a need to do what were called zero-touch onboarding among a number of IETF working groups. And a design team came together from the IETF 6TISH working group, which was a low-power IoT networking group that dealt with primarily industrial IoT. The IETF Animo working group, which deals with enterprise and ISP at the beginning, onboarding of equipment, such as, for instance, routers. And finally, the NetConf working group, which was interested in various kinds of devices and CPE devices that would call home. We had the design team included contributors from Juniper, Cisco, Huawei, and there was a bunch of other ones that went into this. And today, ongoing efforts are currently continue with teams from Siemens, the Google Thread Group, Huawei, and others. So the work started around 2015. RFC 8366 was published in 2018, and that's the voucher document which underpins the commonality. And RFC 8995, which is the BRSKI document, was published in May 2021, along with GRASP, ACP, and the autonomic networking documents. In addition, there was a zero-touch configuration spec, which came out of NetConf, which is SCTP, RFC 8572, and the 8995 and 8572 used the same 8366 voucher format. And you can find a lot of other resources and presentations, including some other interesting animations at brski.org, and there's some icons that we made up to there. We can see there's this guy there in that document. So who is who in this effort? The new device is called the Pledge. This is a little bit akin to what you might see in, say, that old movie Animal House. We show up in college, and as a pledge, you are asked if you want to join a new fraternity. And that's a little bit where this is about. You know, do you want this new device to be able to join your network? The icon for this is the duck, and this is a little bit after a 1999 Ross Anderson paper on the resurrecting duck. And that's a little bit similar, but not quite. But the important thing is that the new device imprints on the network and figures out what's going on. In Ross Anderson's paper, it might be a wolf, and you hope it's not. And there's a whole bunch of biology from a century ago by a researcher named Konrad Lorenz, and you can learn about him, about how ducks turn out to imprint on anything that looks a little bit like their mother. BRSKI's not quite so vulnerable. We try to prevent imprinting on wolves, but there are some configurations and settings where that's more of an issue. So who else is there? Well, we have the network operator. The network has an identity, and cryptographically it's identified by the certification authority, the trust anchor that the operator has. And we use this passport officer with his Wi-Fi in his hand to kind of imply some networking as kind of that representative of the network. And there's actually another one which is a cloud registrar, and we have some new documents of that. So his head becomes a cloud, you can see. Who else is who? Well, we have the device manufacturer, and who is an authorized signer. That's the entity that created the pledge, that manufactured it, designed it, assembled it, wrote the code, flashed it, and effectively it controls all the software that goes into the pledge. In particular, it controls all the trust anchors that are installed. And this is also very critical because that means that there's an inherent trust relationship between the new device and its manufacturer. And that's hardly surprising. Most devices have some kind of a trust anchor involved now, and we're exploiting this to allow for seamless onboarding. So what about zero touch? What does that really mean? Well, it's this process by which a device joins a network without an operator, an expert, having to go and connect to it. The big thing in many environments and many things, not just in residential IoT, but in industrial settings as well, is you just can't walk up to every device, plug in some magic cables and configure it. There's a whole bunch of reasons for this. One is it's just not scalable, but it turns out that there's other issues. For instance, the contractors doing the physical installation may be electricians or plumbers. They're not qualified to do the rest. There may be 3 or 4 layers of contracting involved, and you don't really want to tell them all your network key, do you? Furthermore, network keys are a bit of a problem, and because you can't really kick any devices off without renumbering everything. And so we really want certificates, and that's a little bit more complicated to arrange, and that's why we need a protocol. Well, okay, so why doesn't your laptop have this problem? Well, on the laptop, when you want to join a network, you find the Wi-Fi icon probably, and you open it up, and you authorize your laptop to join a particular network. At some point, you then type in a password perhaps, or maybe you do WP Enterprise or something like this. But effectively, you are telling the device what network to join by virtue of the fact that there's a Wi-Fi pull. On an IoT device, there's no human, there's often no screen, and there's no way for the device to make an authorization decision on its own. So how do we do this? That's the question. Well, BRSKI provides a voucher, and 8366 defines what this voucher looks like. Essentially, in 8366, it's CMS signed JSON. Here's an example of that JSON from our document where it says base 64 encoded value. Oh, well, there's some long, hex stuff that was kind of boring to put this. And the important part is that PIN domain cert. It says to the device, when you see a device with a network with this particular certification authority cert, trust anchor, then you should join that one. Since then, we have some variations. JWS signed JSON, Cozy signed CBOR, and we're going on. And there's historical reasons for why we picked CMS. Why was not what we would pick today, but it made sense 10 years ago. So what does the build 3 look like? Well, so there's some devices on things. We have an onboarding router. We have a couple devices here that are there hooked up. There's some serial consoles, some cabling. And on the far right, you'll see there's a USB thing that's just to power things and also to be able to conveniently turn things on and off if you need to. And the other thing that the decision was that since NCCoE has some virtualization machines, that the registrar, which is the creation of the operator, the representative of the operator, is actually running as a virtual appliance on their ESX stack. If you go into the lab, you can see this. This is a picture of it when it was still in my lab before it got shipped. what does the network look a bit like? Well, I said there was a virtual appliance. It's running on a host, but also there are some equipment out in the cloud. These devices that are called a MASA, the Manufacturer Authorized Signing Authority. And you see there's some other things, and we have one machine that's Titus. It's just there to manage the serial consoles for all the other devices that might be on board. What else is there? Okay, so there's we're running this Minerva reference implementation. It's considered by me to be production ready. Most of the server components, the MASA, which is called Highway, and the registrar are written in Ruby and Rails because they're essentially HTTP services, and so it makes sense to use a production quality framework that does HTTP. Why is it called Minerva? Well, it's the Roman goddess of wisdom, justice, and it turns out in some things it's the Roman goddess of tools and IoT devices. Also, it's named after a fictional character from the Harry Potter series, Professor Minerva McGonagall, and she is well known animagus, a person who can transform into an animal. And as you may know, much of this work came out of a working group called Anima, so it seemed like a good kind of way to play on words here. So there's a component called Highway. That's the MASA component, which is running in the cloud. It represents the manufacturer. And then there's a component called Fountain. It's the network operator's controller. And it's a RFC 7030 registrar. And it has the extensions to do BRSKI. Okay. And it supports a couple other things, including CoAP today. Finally, we have Reach, which is validating client library, which is written in Ruby, which I'll be demonstrating later. And we have a client written in Rust, which is not present in this demo. Finally, there is a join proxy, which is written in Rust, and we don't have time to talk about that, but there are some documents on BRSKI.org that explains how that works and why that's important for bootstrapping and getting online. Hi, this is the demo portion of the Build 3 talk. So what you're seeing is a window where I've logged into a bunch of different systems that are located up there in Gaithersburg. First of all, Titus, you saw the picture of it. It's simply a management system that is not doing anything else except acting as a serial console server and a bit of a jump host to the other machines. Working from the right hand here, we have the MASA. It's a cloud system. It's up somewhere in the cloud, probably a London data center, I think. Then we have the registrar, which is running as a virtual appliance there on the SX vSphere infrastructure and is connected to the rest. These two have a log viewer running, and there's nothing actually to do on them because they'll just do their work. And then we have this machine called Satine. This is a Raspberry Pi. It's a little bit underpowered, so it's actually a bit slow, and I may speed up the video once we figure it out. So I've got it coded to say go and to do its work. It has an IDEV ID, which has been previously created and is synchronized with the MASA. So that's something that would happen at manufacturing time. And it's the topic of Build 6, actually, how that gets involved. It's now thinking, as I say, it's a little bit slow. What it's going to do is it's going to reach out to the Fountain, to the registrar, and what it's going to do is it's going to then say, hey, I'd like to enroll in your network, and is that okay? The registrar is then going to examine the provided IDEV ID, and within it, it's going to find a URL that points to the MASA, and there it's done its work. So it did that, and it sent a voucher request. It stored it away, and it received back this voucher, which connected it to this registrar. So it did a bunch of work, and then it basically went and found, okay, I'm going to go get a CSR attributes to find out what kind of certificate I should do, and then I'm going to send a certificate request to the system. And what we'll see is that there's a new certificate here, which has been newly minted. Here it is, April 14th, a few days before you. And there we go. New certificate created. The serial number in this case is the MAC address that we've told it. It's not actually the MAC address of this device, but that was one way that it would work. And there you go. It's been signed by this root CA, and it now has an LDEV ID part of it. Looking at the other windows, we see that some activity happened here. So we received this request voucher there from 30.103, which is the guest machine. And it looked up in the IDEV ID and it found that this was the name of the So that was a fun demo, wasn't it? I hope you enjoyed it. I'm going to little talk in what little time I have left about what else is coming in BRSKI. So there's three different kind of directions that we're going, and there's been a lot of work over the last 5 or 6 years in these directions for that. So one of which is different transports. We're using CoAP-S instead of HTTP. It's much more IoT friendly. We're using CBOR instead of JSON, much smaller, much simpler. And then the signatures are Jose and Coze for signing the vouchers. The reason for using CMS 10 years ago was that nobody had Jose or Coze libraries that they already were deploying. And in particular, the pushback came from industry was that they did not have a FIPS 140 certified Jose or Coze library, but they did have CMS already out there. So please use that instead. So what else do we have? Well, we have different interaction models. One of this is called BRSKI with PRM, or pledge and responder mode. Normally the pledge is actively discovers the network, reaches out and initiates the process. Well, that doesn't always work. Not all networks are online all the time, and there was actually a significant requirement that came from one participant, basically to be able to bring new housing online while it's still under partial construction. In particular, it's not yet been sold or maybe even finished. The example that was given was we need to connect the thermostat up to the furnace so that the house, which is still under construction, will actually stay warm over the winter. But it's in the basement and there's no internet and there's no LTE because it's a basement. And so actually an operator needs to, a technician needs to actually walk down the stairs, go and do some things, walk it back out to their van and do some stuff. And so we wound up with this other process, a kind of delay tolerant transfer. What else? So we have BRSKI with alternate enrollment, and that uses CMC protocol rather than EST. And again, that's a requirement that came from industry that says, look, we're using CMC everywhere. We don't need or want to do EST. And oh, by the way, when you do this upstairs, downstairs thing, where you don't get a TLS connection for the whole thing anyway, it's going to be broken. So we can't do enrollment over secure transport because we don't have a single transport. So those are some of the things that are coming up. And what else? Okay, so one of the things was the concept of a cloud registrar. So for instance, imagine pandemics just started and you've been sent home to work at home, but the company says, well, you need a phone. And so they ship you a VoIP phone to plug into your network, but it's completely unconfigured and it doesn't know anything about anything. So what does it do? Well, phones today, VoIP phones today, will often be able to pick up their configuration if only they can reach something. Often a DHCP option is extremely popular, but you can't expect people to configure that at their home. So the concept is, oh, it should phone home. But whose home? Well, the manufacturer's home in this case. And the manufacturer will figure out, oh, well, I really sold the phone to Bob at ExampleCo. So I'll redirect them to the ExampleCo registrar. That's that green line. And then we'll do the whole BRSKI process and there. So this document is actually waiting to be published. It's pretty much done. It still does the ownership transfer though, and it can pick up the configuration for the phone. And this is particularly useful because today most of that kind of mechanism is very vendor specific for the phones. And that's about it. I have a couple minutes for questions at this point. Thank you.